So just a recap on the key measures. If you remember, there's some general stuff. I showed you the dashboard. I can show you these in Studio as well. Gives you this information, let's say. So things like the size of your code and what have you, is it getting bigger or smaller, what's happening there. And then we had the structural measures. So these are the objective measures. You'll get these day one. They're independent of any specifications or any architectural vision that the team has and that type of thing. What they're really about is just the raw materials of the code itself. So what they are going to cover are these two aspects here, fat and tangles, where fat is too much stuff, too much complexity at one place at the design breakout. And so I'll go into that again now with Workspace. And then tangles are the cyclic dependencies between packages. So we'll look at that. Then you've got the structure spec, which is a way of defining the layering within your code base, and modules, which is a way of also defining dependencies more and APIs and stuff. So you remember browsing around the structure map, how you can spotlight items to quickly filter the map to just show the things that are dependent on the thing you just spotlit, and then navigating between the map and the code in your IDE. And that navigation, when you navigate from your code to Workspace, that was using the spotlighting mechanism. So you can quickly have a look at the dependencies that go to and from any particular item in the code. And understanding dependency changes. You remember we made some changes. It might affect the layering of the structure map because the layering is a reflection of the dependencies. And any new dependencies were highlighted in a special kind of purple color. So now we're going to look at this next, which is understanding overcomplexity. I'm going to look at fat, and fat is at different levels, the fat methods, fat classes, fat packages, and also cyclic dependencies or package tangles. Okay. And we're going to look at then how you can repair some of this overcomplexity. Now, this is for straightforward overcomplexity. For anything that's not straightforward, you really are going to be reaching for Studio in those cases. But you have quite a lot of information regarding the dependencies in your code base. All the dependencies are there in Workspace. So sometimes that's enough to actually repair a problem. And the key thing here of repairing overcomplexity is what you're doing is you're decoupling and simplifying the raw material of your architecture, which is the code, so that other things become easier. So really what we find people and recommend that people do is focus on this overcomplexity continuously. You can set targets and that type of thing, monitor it in the dashboard and whatever. Put some level of resources into disentangling your code, removing the fat at the class, package, and method level. As you're starting to do, let's say, more big picture, more holistic kind of restructuring activities for other purposes, this will make everything easier. So that's definitely worth doing. So I'll show you, first of all, how we can do some straightforward refactoring, just using Workspace and the IDE. And then we'll be moving into the Structure101 Studio, which is a considerably more flexible and advanced user interface with a lot of advanced features that allows you to start simulating the refactoring. So we can analyze the dependencies. You're going to see the structure map. There are other features in there, tagging, filtering, grouping, and slicing. And then we're going to look at the views. There are different views within Studio that allow you to understand your code base from a different view. And then we'll get into a bit of restructuring. So I'll show you that, the more advanced restructuring. And what you're doing, reducing coupling, increasing cohesion, etc. So back to the same example project that we were looking at. You remember you can expand and drill down just by clicking on things. You can collapse things away. You can spotlight items to do some filtering and that type of thing. You can navigate. Remember, you have to click this link button here. That should be green, which indicates we are linked up with our IDE, which you see on the right-hand side here. What we're going to look at now is the structural key measures here under structure. You see, you've also got two other groupings down here, structure spec problems and modules problems. Within the structure grouping here, we've got package feedback dependencies, we've got fat packages, fat classes, and fat methods. So what we're trying to achieve here is that when you drill down on your package structure here, at every level, you should not see any cyclic dependencies between the packages, ideally. Now, the chances are you've got a Java code base at the moment. It won't be acyclic. You will have cyclic dependencies between packages for sure, and it may be very complex. So it's a matter of picking your battles. So we can talk about that later on, but let's just get the principles well understood first. So everything should be acyclic. And then also, as you drill down, you shouldn't have too much stuff at every level of, when I expand down here, you shouldn't have too much stuff. Let me make a bit more space here so we can see what's going on. You shouldn't have too much stuff here at every level of breakout. That's quite a lot of stuff inside this package here. The more you have, the more difficult it is to understand, the more difficult it is to move code between packages and that type of thing. And also, when you go inside a class, you shouldn't, like, that's a nice size of a class there, okay? And we'll see what a fat class looks like. That one doesn't look particularly fat. So let's look, first of all, at some package feedback dependencies or package tangles, and we'll see what they look like, okay? Here's one here. You've got the three packages here that are cyclically dependent, okay? And we're going to look at that in a bit more detail and see what we can do about doing some simple, straightforward repair work that doesn't really require any simulation. It doesn't require the studio level intervention or analysis. And I'm going to look at, first of all, at this one here, from widgets to C view. I'm going to spotlight just by command clicking again on here, just to toggle the spotlight here. And we're going to drill in on this one here. You see there's a feedback dependency from widgets to C view. It's just got 6 dependencies in that direction. If you remember, the layering is arranged so as to minimize the number of feedback dependencies according to the layering. So for the most part, the dependencies flow from assemblies to C view to widgets. And there are fewer dependencies flowing upwards in the layering diagram. And they're usually, though not always, a good place to start in terms of, these may be the accidental dependencies. If everything uses everything, then the feedback dependencies are less relevant. But let's chase down this one now and see, first of all, what is the cause? Where's that coming from? What is it inside widgets that is using some of the code inside the C view package? I just mentioned there, just while I see it here, at any point in time, if you forget what the UI commands are, what the mouse actions are and things, you can click on the context menu here that appears when you mouse over any item. You can see here, expand, spotlight, navigate to source. And you can also, by the way, copy the name of an item if you want to do that. It just copies to clipboard, okay? So let's expand, drill into widgets here. And what we're doing is we're chasing the source of this red line here, this red feedback dependency. It's coming from this folder layering. Nothing else is in there. So that's kind of good news. That bodes well because it's coming from something at the top level If that's coming from something down in the middle where there's a big tangle, and then you're thinking, uh-oh, this is going to be a tricky one. But here, this looks promising. So I'm going to expand layering now. And inside layering, I can see that that feedback dependency again is coming from a high-level package called Piccolo, and I'm going to look inside there. And now we see it's split. There's one feedback dependency coming from this class here, LW action handlers, which is that one, okay? And there's another one coming from down there in that layering widget class, okay? Now, what I can see immediately here, just by mousing over here, LW action handlers is at the top level of a top level folder. I can see that it's not being used by anything else inside the whole of the widgets folder. Remember, we're trying to disentangle widgets from CView here. It's not being used by anything else. So I'm pretty sure, I'm almost certain, in fact, just by looking at the information here, that if I move LW action handlers up into CView, it'll remove that dependency there. So I'm just going to go ahead and do that. I'll show you how I do that. I'm using IntelliJ IDEA here. Some of you use Eclipse and maybe some use IntelliJ, but there'll be something similar in Eclipse to the kind of thing I'm going to do here. So let's go and have a look at LW action handlers first. So I'm going to do an Alt click, if you remember, if I down here, if I click on the context menu, navigate to sources, Alt click. I'm just going to Alt click to the class itself, not to something inside the class. And it takes me to LW action handlers here. And I'm going to refactor, which is here. And I'm going to move the class. If you remember, I want to move it to CView. So it's basically the headway.cview package is what I want to move it to. So I'm just going to select headway.cview, and it gives me an autocomplete here. I just double click on that, refactor. And now I'm going to do a recompile. You always have to hit that recompile button in order to get what we want here, which is a refresh. And we see there's a lot of purple lines have now appeared. Why have they appeared? They have appeared because LW action handlers now, in a sense, from a Structure 101 point of view, this is a new class. There did not used to be a class called headway.cview.lw action handlers, and now there is. So that's why this is, all of these dependencies are new dependencies because they're coming from what we consider to be a new class. All those new dependencies are not really that relevant. So I'm going to get rid of them now in a moment. I'll show you how I do that. But before we do that, we're going to just observe down here that there is a change has happened. The number of feedback dependencies within core.com.headway has been reduced by 3 down to 11. That's the 3 dependencies that we did have that were flowing up are now no longer flowing uphill. So we made a bit of progress there. And let's just clear the purpleness, if you like, the newness there. You click that button, it sort of indicates newness, I guess, in an abstract way. And if we now look at the feedback dependencies from CView, we still have some. This one here, Core.com Headway, still has the feedback dependencies here from widgets to CView. But if we drill in here now, again, through the layering and through Piccolo, we see that where it did split, you remember it was splitting to the class LW action handlers that was at the top of the Piccolo package. That's gone now because we moved the class up into CView. And now we have just a single dependency down into layering widgets. So let's have a look at that. We drill into there. It's getting very busy, but this is the feedback dependency that we're chasing here. And it's going down to this get tooltip text. That's where it ends up, that method there. Now, if I spotlight that, we can immediately see a simplified filtered graph that shows the problem. Get tooltip text is using this method in this interface and this method in this class. That's the problem there. That's the remaining source of the feedback dependencies. Now, as you are drilling down there, you'll get used to it. It gets kind of busy sometimes. The visualization helps a lot. But when it gets so busy, you have to keep in your mind, what is it you're looking for and that type of thing. Let me show you a slightly easier way to do what I just did. So I'm going to just click on that package again to go to the problem we were trying to fix. I'm going to command click to get rid of the yellow again. And what you can do instead is you can actually just click on that dependency there, which shows us there are 3 dependencies coming out of the widgets folder onto the CView folder. And they're all coming from the same get tooltip text method. I can just click on that now to take me directly to there. And that's where I ended up by doing it, if you like, the more manual way. So that dependency breakout tab down the bottom can be populated at any point by just clicking on a high-level dependency. It will list for you all of the low-level, i.e. the code-level dependencies that are causing that, in this case, the package-to-package dependencies. So that's all goodness, and that's the one we want to have a look at. So let me alt-click on that. It takes me to get tooltip text. And what we're looking for is the get add entity strings and get instance references. And if I remember rightly, they are down here. There's the get instance, and there's the get add entity strings. Now, these calls, these method calls, are inside a bit of code that constructs the text for the tooltip. So I can, I guess, quite easily remove that. Now, it's going to make a mess of my tooltip in this case, so I probably wouldn't want to do exactly what I'm doing here. But for demo purposes, let me just delete that there and then hit compile. And then go over here and hit refresh. I'm going to do the incremental refresh this time. It's a bit quicker, and also it will preserve any new dependencies. Now, in this case, there are no new dependencies. There's no purple happening here. The reason being that we just removed some dependencies. We didn't add any dependencies this time around. And if we go over to the problem items here, we can see that we've further reduced the number of feedback dependencies within core.com.headway by 3, and it's now at 8. There are 8 remaining ones. So let's have a look at what we just did there, and you can see what we did. We removed widgets. Now is finally, after those 2 changes, widgets is no longer in a cyclic dependency with these other 2 packages here. Widgets is now out underneath a much happier looking, or incrementally happier looking dependency situation. And we would go ahead and do something similar. Perhaps we'd explore, why is there a feedback dependency from CView to assemblies? That would be the next step. But you get the kind of general process here. We're gradually teasing apart these packages. And in this case, it was quite easy to do. We could just do it in the IDE. A combination of the information in the visualization and then editing the code in the IDE was all we needed to do. Sometimes, actually a lot of the time, that's not going to be as easy as that. You're going to look at some of these dependencies and you're going, oh my gosh, you know, I'm going to have to move 20 or 30 classes around the place. That's where you're probably going to reach for Studio. So that's what cyclic dependencies look like. That's how you can kind of repair them relatively easily using the dependency information in Workspace. Let's take a look now at some of the FAT. I'm going to start now at the FAT methods level first. okay? What we count for fat at the methods level is basically cyclomatic complexity. It's the number of paths through a method. How many possible execution paths are there through a method? And what drives that number up is the control structure. So the number of nested while statements, for loops, conditionals, case statements, that type of thing. All those things increase that number, and especially where they're nested. Nesting is kind of a multiplier of the number of potential paths through something. And if I click on something here, let's just take a look. This one here has got 55 execution paths. So let's have a quick look at that. When you click on something in a list, it will take me to that item. So I see it within the visualization. So I can see where is it in my overall code structure. And here are the dependencies, gives me a bit of context. To navigate to the code itself in the IDE, I need to alt-click on the item in the visualization. So the path is from a list to the visualization, from the visualization to the IDE. Here it is, S101 POM model. So let's have a quick scan of this and we can see what a fat method looks like. And you can see here lots of nesting of if statements, if then else, all nested, and it goes on and on. Lots of indentation is what I expect there. And in it goes. That's what a fat method looks like. There's actually way too much stuff in this method. And I don't know if I can think of any examples where it's impossible to break up a fat method into smaller methods, each of which is below threshold. There's no real reason for making something this complex. And the way you would do that is by grabbing some of usually one of the groups in here and moving it into a method. Let me find something that's a little bit more manageable. I'm going to take, let's try this one here. So these are 16 is the fat number, i.e. the cyclomatic complexity number in the case of a method. It's 16. The threshold is 15. So we don't have to make much of a change to this method in order to bring it below the threshold. So I'm just going to go ahead and do that. So I alt-click on that one there, and here's the code. There's a bit of nesting here. There's and as I say, it's just slightly above what Structure101 considers to be too much stuff. And what I'm looking for inside here is a reasonably self-contained block of code. I'm going to grab this for loop here because I can see if I remove this, I'm definitely going to reduce the cyclomatic complexity, right? So I'm going to grab that code, that block of code I've just selected. And what I want to do is move it into a method. And instead of having the block of code in here, I will have a call to a new method, which will contain that block of code, okay? And the IDE does most of the work for me in this case. So I'm going to do an extract method. It suggests I call it extracted. Actually, I'm going to call it something check for inner classes is what the comment says. So I'm going to be check for inner, let's say. And you can see there, now there was a block of code there, whereas now I've got a reasonably named function call. So that already, you can see how it just simplifies when I do that, okay? And down underneath here, I've got this check for inner now has been created for me by the IDE with that for loop in it. So a little simplification. So you can imagine doing this even on a 55 cyclomatic complexity. You would start with some bigger groups and keep chunking them away until you've got it down below the 55. I hit a refresh here and a refresh here. And we should see that class, that new method appear. There it is, check for inner. Okay, now in this case, in fact, it was a recursive function. Now it's a mutually recursive two functions. That's why they're inside that red block there. because they're cyclically dependent, these two, okay? But if I go down here now, I can see my structure. My measures have improved overall by -1 because the fat methods have been reduced by 1. And there it is there. That guy there now is below the threshold. That's an immediate improvement on my structural measures that are going to be picked up by the dashboard, by SonarQube, that type of thing. This is how I'm driving those numbers down. So that's what a fat method looks like. That's what repairing a fat method involves. Fat classes then. Let's have a look at some fat classes. Here's one here, 291. In the case of fat classes, we follow the same principle as fat methods. What do I mean by that? Fat methods, we measure the cyclomatic complexity, i.e. the number of paths through the method. We don't just measure the number of lines of code in a method. The thinking here and the thinking behind McCabe's metric or cyclomatic complexity is that it is the complex nesting of control flows that is hard to understand and that is hard to maintain. A serial list of 100 lines of code without any control flow in them, although you might say 100 is unnecessary, at least it's pretty easy to understand. It's just, they all happen sequentially. You can walk your way through. Whereas when 100 lines of code that is heavily nested is much harder to understand. So that's why we pick that one as a measure. In the case of a fat class, we follow the same principle. We don't just count the number of methods in a class. What we're actually counting, if I switch it on here, there are visual controls here, is all of the method to method and method to field dependencies within the class. That's what we're looking at, okay? And, you can't see them here, but as I mouse around, you can see there are a lot of methods, but in particular, what we're counting are the number of method to method dependencies, if you like. Okay, so that's what it looks like. Let me look at another one here. LM cell, there's another one. The threshold in this case is 120. So it's 15 for the number of paths through a method. But when you get to the class level, we're actually counting the number of dependencies between the children of the class, i.e. the methods and fields. 120 seems to come up with a reasonably sensible limit. You don't want to be too draconian. You can always set that limit to something lower, but first of all, get all of your classes down to 120, and then you may choose to be a bit more extreme if you like. 120 seems to be not too bad. There you can see one that's slightly over the limit. It doesn't look too bad, right? There's quite a lot of stuff in it, but it's not too bad, basically. There's a trick you can use in Studio to help you with fat classes in particular. They're a bit more tricky to do just interactively, but you do have the information you would need here. You might choose something here as a root and start, spotlighting the dependent. You might say that plus all the things it uses might make sense. There are various things you can do here to pull together a subset of the class into a new class is what you're ultimately going to want to do. I'm not going to demo that. The class level stuff is also more tricky because it's object-oriented. When you create a new class, now you have to think, well, how are the people that used the original class going to get the new reference to the class that I'm now extracting out of a class? And all of that becomes just a bit more complex and not something that's easy to do in a relatively short session, let's say. But you get the idea. What you're going to have to do is pull a cogent set of stuff out of this class into a new class and then join up the references. I will show you, however, a fat package and how to repair a fat package. Let's have a look at some fat packages. Within a package, you're going to have a combination of sub-packages and classes. And what we measure for the fat of a package is the number of dependencies between that package's sub-packages and or classes is what we measure. And that's what you're looking at here. Again, you've got, probably just too much stuff here. You've got all the dependency information to break it out. And in some cases, it's easier than others. Some cases you may want to go to Studio, and I'll show you some tricks in Studio for this kind of thing. In this case, actually, there's one here. I think it was this one here. It has an interesting attribute to it, which is I notice as I'm looking at this one, the sub-packages of HighView here are at the top level, the top row here. And then there's a few in the next level down here. Okay. And there's one down the bottom. They are the packages. All the classes are in the middle layers here. Okay. And just by mousing over, I am 100% certain that if I were to take all of those classes and push them down into a new sub-package, I would end up with an acyclic package structure within HighView that I'm pretty sure now, because there's relatively few of them, I'm pretty sure would be less than threshold. So I'm just going to go ahead and do that so that you can see the end result. So remember, when you are breaking up a fat package, obviously you can go through it and you could grab all of the classes in alphabetical order and take, the first 20 of them and shove them down into a sub-package. And then you could get the next 20 and put them into a sub-package. But what you're almost certainly going to do if you do something like that is you're going to create cyclically dependent packages. The new packages that you're creating will be tangled. So you need to really look at the layering when you're doing this. So I shall say no more. I'll just go ahead now. I'm going to show you here, because this is a handy way to do it, let me collapse that away there. I'm going to alt-click on the package itself here. And that takes me to the HighView package here. What I want to do is I just want to grab all of the classes at the next level down. So I'm going to go down to the first one here, and then I'm going to shift-click. Multi-select all of the classes, basically. And then I'm going to refactor. Move the classes to a new sub-package, which I'm going to call, let's have a look at what's inside here. Let's say relationships. Let's say it's to do. I'll look at them and see what do they look like they're related to. And you want to be careful. It looks like there is already a relationships there. So I don't want to confuse things, make sure I don't get, just let me say HighView.classes for now. .classes. If I do refactor, it'll prompt me to create the new folder. And hopefully it does it. It tells me sort of what's going to be impacted. I say, yep, go ahead and do that. And it's doing a whole load of changes here. If you think about it, anything that uses any of these classes that I've now moved, it has to go to all the client classes and make sure that the import statements are adjusted and that type of thing. And I hope that that's done the job. Let me just see here. And let me just command it. And did I just do? Oh, I've done a lot of changes here. Did I do a compile? I may not have finished the compile. I need to just finish the compile, and then I'm going to hit refresh again. A lot of new stuff there because you'd expect that. So I'm just going to go ahead and clear the new stuff. It shows the new dependencies by default, so it's always worth getting them out of the way if there's a lot of changes. And you can see here now, there's that classes package. You remember what it looked like. That high view package, just even from the visualization, was not an easy package to understand because I have to go look at all of the classes to understand what the high view package was about. Now I can see that it just contains a nice handful of sub packages here. And hopefully individually I can drill into those and understand what they are doing at the next level of granularity. And here I can just see, yeah, that all looks much better. And within the classes, then I've got these things in here, and hopefully they kind of make sense. But that little bit of tidying up, the intent is that every time you expand something, be it in a tree view over here, or more particularly inside the structure map here, when you expand any module or package or class, you're going to see at the next level breakout, when you do that expand, there's what they call like a mind-sized chunk of new stuff will appear that you can understand in its own right. So that's one of the benefits of reducing fat on a continuous basis. And also, once you've done this kind of thing, you will find that the code ultimately becomes much easier to refactor. If you can get it to the point that all of your breakouts are mind-sized chunks and none of your packages are cyclically dependent, now you've got a lot of flexibility to move, let's say, chunks of stuff. Maybe I want to grab some packages and move them into a new module and that type of thing. You can do that kind of thing relatively easily now without creating cyclic dependencies, which are impossible to manage. You can't do cyclic dependencies typically between Maven modules, for example. Whereas when everything becomes acyclic, you can start refactoring at a large scale much easier. And also ongoing development activities tend to have less impact. You move away from everything breaks everything, right? Because you've just got a finer grained level of dependency. I think at that point now, we've sort of covered all I want to cover as a first pass on the workspace stuff here. And I'm going to move across now to Studio. This is the user interface here to Studio. What I've created here is, in this case, you set up, where's my bytecode location? Because you will be using Workspace, what you're going to point to here is what's called a HSW file. That HSW file is created inside your IDE. You'll see there's a place where you can change that. I guess it has a default, but you can set it to wherever you want to keep the HSW file. That is where the connector plugin to your IDE dumps information about your project. So it says, where are all the modules? How are the modules dependent on each other? And where is the bytecode being compiled to? The bytecode is what drives all of the other Structure 101 information gathering. So Workspace will point to that, and Studio will point to that. So that's what we've got here. You've got, that's what that is. You can adjust the granularity unless you've got a very huge project, you want all the details in there. And normal stops the model at the class level, basically. So you can't drill into classes. It means your model is a lot smaller, but it's very useful sometimes for doing some basic tidy up. Externals is whether or not you want to look at things that are not part of your project, but they may be external libraries. You can pick up references to those without actually parsing them, okay? Modules will come back to. Excludes is kind of useful. This is where you can exclude stuff that you just don't want to include in your module. So for example, if you had automatically generated code, you might say, look, just leave that out of my module. Okay. So that's the project settings. Different ways to set up a Structure 101 Studio project. We won't cover all of them right now. Let's get straight into the UI now. you've got 4 tabs here. This is the structure tab. And this lets you do, instead of single click, it has a selection mechanism when you do a single click. So to expand, I need to do a double click. Okay, and I can double click again to look inside classes. Okay, but other than that, it's very similar to what you were seeing in Workspace. I can drill into core, double click, I can drill down. There's a tangle. Instead of a red box, it's actually a red region. So you're always aware of whether or not you're inside a tangled region, even if I go down another level now. Okay, that red region will kind of spread all the way down. You know you're in a tangle when you're in a red region. You can control, however, in fact, you can collapse these tangles if you want to. You can't actually do that in Workspace. And you can also control whether those tangles are displayed from here. That lets you deselect that option. Sometimes you'll want to do that. There's this option here to show the feedback dependencies all the time. If not, it'll show you the feedback dependencies only when you select an item, okay? I would generally work with always show me the feedback dependencies. I can, if I want to, show all the dependencies. You can do that. Very quickly, that gets too busy, but sometimes that is useful. I usually would use show dependencies only when I select something. So the layering tells me the basic dependency structure, and then when I select something, I can see the details. And I can drill down. I've got all of the top level. This isn't a complete list here, but I've got all the top level fat and tangles here. By top level, what it generally means is it'll show you this core.com.headway has a tangle in it. There it is. If there are tangles within core.com.headway, it may not show them because you've already captured the problem at one level. It sort of tries to give you the most significant stuff, let's put it that way, starting from the top of the structure. There is also a really handy thing here, same as actually in Workspace, where if I select any dependency, I can see the breakout of that dependency. And you can do that from basically anywhere. If I want to see what is parser Java X using within util, well, select it there. And there's a list of all of the code level dependencies at that level. Okay. I can also do things like tagging. Okay, I'll just mention it now and I'll show it in use when we start doing some refactoring. But when I tag something, it gets this blue dot. It's just marked. It's like a persistent selection. But it also means that when I go here, you can see there's a pale blue dot here. That means that core has something that's tagged in it. And I can say, oh, it's inside here. It's a way to sort of drill down on things. And now because I tagged foundation here, everything within here is tagged, okay? At any point in time, I can look at the map contents here. This is really useful for finding things because it gives you an alphabetical list of all the items that are in the current view. I can do things like within the map contents, I can say, just show me the tagged items. There are the tagged items. Now, if I expand that, there'll be a lot more tagged items, but I can do that. I can say, show me all the dependencies in the current view. There they all are, all the dependencies, and I can navigate from here to each of the dependencies as I wish. All of this stuff, super useful when you're doing different forms of analysis and restructuring activities. Anything else here? Filtering. If I want to work on this tangle, for example, you got filter in and filter out. Okay. Let's say actually for the minute, I'm not interested in brands. I can filter it out. Douche, gone. If I want to work on this tangle, I might filter it in, which means actually hide everything else. There it goes. I can go back in the filter stack to the previous filter view. And we're back here, brands is still not shown. I can filter in or filter out on the tagged items. So I have foundation is tagged there. So if I hide it, it goes away because it was tagged. Go back in the stack, I filter it in. I've isolated foundation now. All I'm seeing is the filtered stuff. This is quite important here. This is the where am I in terms of structural overcomplexity. And you can see on one dimension, you've got the tangles. The other dimension is the fat. It's measuring the percentage of my project that is in a tangled region. In this case, it's looking like about 40% or so is tangled and about maybe 30% is in a fat region. And what I'll be doing as I'm refactoring, simulated refactoring here, moving things around the place, is you'll be seeing that dot there moving down towards the origin, which is where you've got, if you like, a code base without any structural overcomplexity. So that's that basic view. Overlays is where we're going to do specs. There are two types of specs, structure spec and architecture diagrams. There is nothing there by default. We're going to have to create those when we come to defining our architecture. And then the views. When I click on the views here, you can see I've got a whole bunch of them here that I can look at different aspects of the code base. Across these dimensions here, various split packages and notables and stuff. But the complexity one, because it ties in what we've already been talking about, again, this is talking about where is all the over complexity in my code base. I can see here that whatever that is there at 15% or so, actually, if I mouse over it, it shows that the over complexity is about 9.4%. The majority of that is due to a fat packages, and there they are when I select them here. But I also have some fat classes, a few of them here. I've got a whole load of fat methods here, but because methods are quite low level, they don't contain as much code as, say, a package, they don't count as much towards my over complexity as a percentage of the code base. And we have some tangled packages here that are also causing some of the problem. I can drill down. So if I select, for example, my fat packages, I can drill down here. I can sort on this. This is actually quite useful just to understand where is all your code. Here you can see nearly all our code in this particular example is inside a single module called core. Not unusual for that to happen. And often your restructuring activities will want to be breaking out that million lines of code module so that you have, let's say, 10 modules instead that each contain 100,000 lines of code. Much, much, much easier to maintain that code base. So we'll come back to that. And I can drill down then on this and I can see where is the code and where is the redness and where are my problems, you know, fat classes, etc., in all the different categories. So we'll get into the real sleeves up stuff where we're actually changing stuff in the code base. I'll do some simple refactoring, if you like, or basic refactoring, which is disentangling of packages. I'll show you how we're going to, in an example, move that dot down to the origin, in essence. I'll show you that. And then, so that's just blindly following the over complexity measures. Then I'm going to take a situation like this one here, where we have a whole load of code in this monolithic core here. And I'm going to show you how we can figure out a way to extract specific features out of the core package and put them into a new module, out of the core module and move them into a new module.